I forgot to do something there. Another way of combining two functions of the form is if you have a function x squared, another function x plus 1, the composition of f with g is called f of g of x. So if you're looking there, that's what they're telling you. So they say, when you do this kind of function, you start with g first. So they're saying, take the function g, x plus 1. If you plug in x, you get x plus 1. Take that answer and plug it into f. That's what they're writing there. So they're taking that x plus 1 and plugging it into x squared. So you get x plus 1 squared. They're saying f of g of x is the same thing as f composed with g, or f circle g. Please note that is not fog. Some of you will be lost in the fog. I don't know why. It says, definition, the composition of the function f with the function g is f of g of x, which you can write as that way. F circle g, or f composed with g, is the same of f of g of x. The domain of f circle g is the set of all x in the domain of g, such that g of x is in the domain of f. So they're saying right here, if you do f circle g, you start with g first, and then you plug it into f. That's what they're telling you there. Again, if you look at the other page, you should know, if you have any functions, you can add them, subtract them, multiply them, divide them. You can never have 0 in a denominator. So again, adding, subtracting, multiplying, dividing. They give you the rules right there. The sum rule, the difference rule, the product rule, and the quotient rule. When you divide, you can't divide by 0. So you always have to check the restriction, the denominator. With that out of the way, we'll do examples. Number 1, f of x is x squared. G of x is 1 minus x. They want you to add the two functions. So if we do f plus g of x, we get x squared plus 1 minus x. Pretty straightforward, right? We can write it in standard form. We get x squared minus x plus 1, descending order. Now they want you to do f plus g of 2, which means you take the function x squared minus x plus 1, and you plug in 2, which is 2 squared minus 2 plus 1. That's 4 minus 2 plus 1. That gives you 3. And I box that puppy. And we're done. Wasn't that sweet? Next one says, given f of x is x squared, g of x 1 minus x, they want you to subtract the functions. Evaluate the difference when x is 3. So we go f minus g of x. That's x squared minus, we have to put that in parentheses. Most of you forget to distribute the negative. You have to distribute negative there and there. These are the mistakes you make in precalc. X squared minus 1 plus x. You get x squared plus x minus 1. I should have boxed that puppy, because that's f minus g of x. That was f plus g of x. I should have boxed that. Now we're doing f minus g of 3. So you take the function x squared plus x minus 1, and you go 3 squared minus 3 minus 1. Or was, let me see, I did that wrong. It's plus 3. Almost made a boo-boo. That was my lazy eye. See that negative? I picked that up. I should have been looking over here. So you got to watch what you're doing. Remember, when you do math, you always got to be careful. So always double check your work. When I work that out, I get 9 plus 3 minus 1. That's 12 minus 1, which is 11. And I boxed that puppy. Any questions? So this is pretty straightforward stuff. Moving right along now. They want f times g of x. So we're doing f g x. Note there's a little dot there, but they didn't show it. I'll put it there. So that means I take the function f, which is 5x plus 2, the function g, 3x minus 4, and multiply them. And we can do that by FOIL. If I do that, I get 15x squared, first terms of each parenthesis. The outside terms, negative 20x. The inside terms, positive 6x. And the last term is 2 times negative 4, negative 8. That's 15x squared minus 14x minus 8. I'm sure you ate that up. No, negative 20, positive 6 is negative 14. 2 times negative 4 is negative 8. Now they want to do f of g of 2. F times g of 2. So if I write my function 15x squared minus 14x minus 8, and I plug in the 2, I get 15 times 2 to the second power minus 14 times 2 minus 8. That looks like 4 times 15 is 60 minus 28 minus 8. 14 times 2 is 28. That looks like 60 minus 36, which is 24. And I boxed that puppy. I should have boxed that puppy up there too. Okay, always box your answers so I know where they are. Any questions on that one? Looking pretty easy, huh? Next function says divide. F over g of x. If I do f, its function is x squared, all over 1 minus x. There's nothing I can do there. That's the answer. Oh my God! How nice! What's the domain? When you're finding domain, where do you look?
The zeros.
When you're finding domain, where do you look?
The denominator.
Denominator. What is the denominator?
The 1 minus x.
Yeah, you're looking right there. Denominator. People better know what a denominator is. That's another vocabulary word. So we go x minus 1 equals 0. X is 1. If you let x equal 1 there, it's undefined. So you have to draw a number line. On the number line, I put the number 1. I can't have 1, so I put an open circle. Can I put in 2 into this function? Can I put in 2?
Yeah.
Can I put in 3?
Yeah.
Can I put in 1,000?
Yeah.
So I know that's 1 to infinity. Remember, this is infinity out here. That's one interval. Now I'm going back the other way. Can I put in 0?
Yeah.
Can I put in negative 5? Can I put in negative 1,000? Yeah. Negative 1,000 squared over 1 minus, I can do that. That's what you're doing when you do domain. Can I use those x values? So we write a little u there, and then we write we write 1 to negative infinity. That says all reals except 1. Most of you know this is reals not equal to 1, but you're going to write intervals. I should have put 1 there. Reals not equal to 1. You're going to use interval notation. This is what you got to get in the habit of doing, and that'll be on the next quiz. You have to know how to do intervals. That's why I point that stuff out to you. Any questions on that side of the paper? Pretty quiet today, people. Well, then turn the page. Don't make Mr. Carroll rage. There we go. What's the one? It's a composite function. No, that's a composite. How do I know? It says F circle G. That's not fog, which is the same thing as F of G of X. So that notation and that notation are the same. So this says start with G first. So I'm going to highlight this for you. That's what you do first. So we set it equal to 4x squared plus 1. Now you're taking this x and you're plugging it in there. So it is 4x squared plus 1. It stayed the same because you plugged in x. You're taking that answer and plugging it into function f, which is 2x plus 5. So you're taking that right there and you're plugging it in for x. So I get 2 times plus 5. What am I plugging in? 4x squared plus 1. Distribute and simplify. You get 8x squared plus 2 plus 5, which is 8x squared plus 7. F circle G of x equals that. Now a lot of kids will go F times G there. If you do, that's not the same. Note that has an open circle. This means multiply. This is a composite. Means you plug one function into the other function. This time we're doing the next problem now. Is there any questions on that one? We start with function what there? Can't hear
you. G.
No.
F.
See the yellow? We always start with there first. This is first. That's where you make your mistakes. Start with the inside. F. F is what? You're going to plug the x in there, and it stays the same. When you plug the x in, which I'll do in red for you there, it stayed the same. Now you're taking that answer and plugging it into function g, which is 4x squared plus 1. You're going to take that 2x plus 5 and plug it in. So you get 4 times something squared plus 1. What are you plugging in? 2x plus 5. Now you get these problems wrong because you don't write them out. That means 4x times 2x plus 5, 2x plus 5. A lot of kids will write 4x squared plus 25. If you do that, you get spanked. You get to FOIL. 4, that's 4x squared. First term. Outside terms, inside terms is 10x, 10x. Plus 5 and 5 is 25. Plus 1. Don't forget the plus 1. You can combine the like terms. 4x squared, 20x, plus 25, parenthesis, plus 1. Distribute. Boom. 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 16x squared, 80x, plus 100, plus 1. 16x squared, 80x, plus 101. And I boxed that puppy. Should have done that for the other one too. That's G circle f of x. Any questions on that? Can't hear you. Any questions on that?
No.
All right, let's plan on the next one then. What are we starting with, F or G?
G.
All right, so we set it equal to g. G is 4x squared plus 1. What are we plugging in for x? I can't hear you.
1/2.
What's a half squared?
1/4.
4 times the fourth plus 1. What's that?
1.
1 plus 1 is what?
3.
2. I'm shocked and dismayed. So right there, I use function g and I got 2. I have to plug in 2 to function f. What's function f? 2x plus 5. That's 2 times 1 plus 5, which is 7. F of 2 equals 7. Actually, I wrote that wrong. I should have said F circle G. F circle G of 2. My bad.
Mister,
Yes, sir. Go ahead.
wouldn't it be 9 because you have to plug in 2 for x?
Oh, I forgot the 2. Yeah. I plugged in 1. You're right. I'm glad you're listening.
Thank you.
2 times 2. See, there you go. 4. See that, what I did there? I put in a 1. I don't know why I did that. 4 plus 5 is 9. There you go. You're right. Good job. Let me make that 9 better. There you go. Oh, here we go again. Any questions on those 3? Now they're giving you a square root function f and a parabola that has a vertex 0, -4. You should keep that stuff in mind. See, they're throwing all these functions at you. That's what I told you they do in pre-calc. What are we starting with here? F or G?
G.
That's right. So it's x squared minus 4. If we plug in x there, it stays the same. And we're doing f of x squared minus 4. What's function f?
Root x.
That means you're taking that right there, x squared minus 4, and you're plugging it in. So we get root x squared minus 4. F circle g of x. And I box that puppy. Now comes your test problem. Hopefully you know what to do. What's the domain? What do we do?
You have to set root x squared minus 4 equal to 0 and solve for x.
There you do. You're a smart man. Good job. Root x squared minus 4 equals 0. How do you solve that?
Square root on both sides.
Not square root, square.
Oh yeah, square on both sides.
And you get x squared minus 4 equals 0. You get x squared equals 4. You do the square root. What do you get?
2.
What do you get?
2.
What do you get?
Oh, a plus or minus 2.
There you go. You better know that stuff.
Yeah.
Because x squared minus 4 is x plus 2x minus 2. If you want to factor it, you can do that. That's why you factor it. Or you can do radicals. They're in pre-calc now. You're supposed to use your intellect. Now we have to do interval notation. I'm going to ask you questions. Be ready to ask. Answer, I mean. Here's 2. Here's -2. Can I take and plug in 2 into this function? What's 2 squared?
4.
4 minus 4? Can I do the square root of 0?
Yeah.
So I can use 2. Can I use -2? See a dark circle there? -2 squared is what?
4.
Minus 4 is what?
0.
Can I take the square root of 0? Yeah. Now what do? I have to test points. I take point to the right of 2, which is 3. A point between 2 and -2, the easiest one to use is 0. And then I would take -3. and see if they're true or false. Can I do 3 squared minus 4? What's 3 squared minus 4?
5.
5. Square root of 5, can I do that?
Yes.
So this is 2 to infinity. You can use anything bigger than 2. Can I use 0 there? If I plug in 0.
No.
Why not?
Because it's a negative 4, so it'd have to be like 4i.
Yeah, so we can't do that. So we write union. Can I use negative 3? What's negative 3 squared?
9.
9 minus 4?
5. Root 5.
Yeah, I can do the root 5, right? So you go that way. This is what you used to do in algebra 2, but now we're going to write interval notation. That's negative 2. Bracket, because we're including the point. This is negative infinity out here to negative infinity. That's interval. That's interval notation.
I have a quick question.
Fire away.
What's the U?
That means it's combined with it's a union.
Oh, okay.
That's a union.
Okay.
That's all they're saying.
Yeah, I
It's
see.
that part plus that part. All right? That's what we do when we do interval notation. That's the notation. If those were open circles, that would be a parenthesis on those 2's. So you got to know the difference. If you can use it, it's a bracket. If you can't use it, it's a parenthesis. The last problem here says the weekly cost of producing X units in manufacturing process is given by this function. So the cost is by this function. The units produced is given by that function. They want C circle X of T. A lot of kids get confused here because they put that T there. What function do we start with first?
X, so equal it to 42.
So it equals to 40t. If we plug in the t, it stays as 40t. We're taking that and plugging into c. Function c is 48x plus 150. You're taking the 40t and plugging it in for x. That's 48 times 40t plus 150. No, it's 1150, my bad. 0. 4 times 8 is 32. 4 times 4 is 16, and 3 is 19. That's 1920t plus 1150. That's C circle X of t. And I box that puppy. But now they want you to interpret what that means. What does that mean?
That's the rate of cost production.
It's the cost of producing. If you look right there, it says T units. And there you go. Wasn't that fun? Any questions on that?
Nope.
Ladies?
Nope.
Beautiful. Now we're going to take out, remember all our worksheets we had? I put them on the line there. Oh, look at there. We're going to take a minute and two, and you're going to do this worksheet right here, right now. Because this is what's on your next quiz and test. You should know how to do this stuff. So right here, they want you to take this function right here, and they want, see that graph right there? Boom. They want you to take the function, which is that graph, minus 2. They want you to do f of 2x. They want you to do the negative in front of the function x plus 2. So it says, match each transformation of the function listed below with its graph from the bottom of the page. The original graph is the function to the right. So, if you look at this picture, We'll do the first one together, because I'm a nice guy. I tell kids you should take a look at this graph and maybe call that 0, that 1, that 2, that 3, that 4, that 5, and that's 1, that's 2, that's 3. You know, just label the graph as units. And they're saying this function is going down 2 units. So first off, I'd write it's down 2 units vertically. That's the description. Which graph is that? If you look at all the graphs there. So see that 2 right there? Right up here at the top? That's looks like 2, 2 to me. I just fudged it. So where did 2, 2 go? If we went down 2 units, we'd be just below the x-axis there. Which graph is that?
H.
You're right. So see how easy that was? What's the 2 inside do?
It's a horizontal stretch of 2.
He said it's a horizontal stretch of 2. Do you all agree with that or no? This is what you have to know. This is why I'm talking to you. I want you to know this stuff. Because if you don't, when you do the problems, you get spanked. He said it's a horizontal stretch. Do you agree with that? Ladies, gentlemen? Hi.
No, it's a horizontal shrink of 1/2.
Thank you. It's a horizontal shrink of the reciprocal. Remember that. It's reciprocal. Mr. Carroll pointed this stuff to you. If you have c times f of x, it's a vertical stretch if c is bigger than 1. If it's c times the function between 0 and 1, that's a fraction less than 1, it's a shrink, a vertical shrink. When you're plugging it into the function, the c into the function, greater than 1 is a shrink, less than 1, greater than 0 is a stretch. It's the reciprocal. You got to keep that stuff in mind when you do horizontal. So you do the rest. So I'll write here horizontal shrink magnitude 1/2. Then you got to figure out which one that is, what graph that is. Now you could take a few minutes there and buzz right through them. Boom. This stuff fun. So keep in mind you should be doing some of these problems when you get to these pages. I know a lot of kids like to skip over this stuff, but this is how you learn. You know, discern, learn. Bear in mind, I did notes with you the other day, just to show you here. I told you these are the vertical stretches, right here, and the vertical shrinks. That's what it does to the graph. This one's the horizontal shrink. This one is the parent function, and that's the stretch. You should note what the graph does. That will help you when you look at the graphs. That's why you have to know what vertical and horizontal are. The shrink here for horizontal squishes it closer together. The stretch vertically is right there. Remember, that's c times f of x. And this one is a f of c of x. That's what's going on there, as you're plugging in the c to the function. That's why I write these notes out for you, so you can see what's going on. How are we doing? Give you another minute or two to catch up, finish it up. You should know what's going on here. Boom, boom, boom. Some of you are going, what the heck is he talking about? I'm talking about you, people. You. Let me see your smiling faces. Guess I can't get there. Oh well, I tried. Maybe it's this way. Look at them working. They're working. Emily, how's it going there?
Good.
You got them done?
Yeah, almost.
Almost. Ava, land of the Brava. Bryce, how's it working? How are you going?
It's going well.
How far are you?
I'm almost done.
All right. What's almost?
Got like 2 or 3 more.
Okay. I just want to know for time's sake.
Yeah.
My advice to you is run through here and then go through and describe what's happening here. The number 3, you should be able to say what's happening real quick. What's happening there? Who's telling me?
Reflection over the x and a shift of 2 to the left.
Okay, so it says reflected over x, so I'll write r of x. That's why a reflection of x, that's how I write it, so I don't have to write out all that stuff. Then it shifted 2 units horizontally left. So it says 2 units horizontally left. Look at the next one. What's that? Can't hear you. Number 4, describe it. I'm not worried about the graph right now. Describe it. What's the 2 in front mean?
A vertical stretch by 2.
Stretch factor of 2. Or magnitude 2, whatever you want to say. And then what's the negative do inside?
Reflection of y.
Reflects it over to y. Thank you. Look at the next one. What's that? Anybody?
Y divided by 2.
What does that mean?
The y values are half of what they are, but the x's remain the same.
What kind of transformation is that?
A horizontal shrink.
Oh no! If you rewrite the problem, it says a half of f of x. See, that's the same thing as saying a half of f of x. What's the half in front do? Which is the
Changes the font.
right?
Vertical shrink.
It's a vertical shrink, factor of a half. Vert, shrink, magnitude of half. That's a. What's the next one? What's the next one? Number 6.
Translation 2 units right.
So you say it's not a translation. You say it's a 2 units
Shift.
horizontally right.
Yeah.
What's the next one? What's the negative in front, Joe? Can't hear you.
Reflection on the x-axis.
Reflection in the x-axis. And what does the x over 2 when it's plugged inside do?
Horizontal stretch by 2.
Horizontal stretch by 2. I'll write H stretch by 2. Remember, it's a reciprocal. What about number 8?
Reflection over y-axis.
Reflected over Y?
Yep.
And then what?
Shift 2 units up
Up vertically.
vertically. Yep.
Got to know what horizontal and vertical mean. What's the last one?
Vertical stretch by 2.
Vertical stretch. Back magnitude 2. Vert stretch magnitude 2. And then what?
It's going down vertically by 2.
Shifted down 2 units vertically. Now we do the letters. That's what I would do if I were you. Most of you don't. You just guess. So what's the letter for number 2? Anybody?
C.
Nope. We said it's a what? A horizontal shrink. What does the shrink do? C is wide. Look at right here at the graph. Squishes it together. Which is try again.
B.
It is B. What's next? Next one. Anybody?
G.
It is G. Does everybody see G? G. See it says? It says 2 units horizontally, and it's reflected over the X. When you reflect it over the X, it flips upside down, because this is the X-axis. So if you're looking at the graph, it goes upside down. What about number 4? Number 4.
I.
You said I? Now let me see. Number 4, you're saying it's a vertical stretch magnitude reflected over the Y. So you're reflecting over the Y, means it's going to flip over the Y axis over here. And you said I, so if I look at I, but it's a vertical what? Stretch. Let's see what a vertical stretch looks like. See a vertical stretch? This is why I draw these graphs for you. So what happens? It pushes it together. Is that a good choice? That looks like it's more wider. Try again. It's F. F, F, F. That's why you have to know what a stretch is and a shrink is, people. Because just looking at the graph, you're supposed to know that stuff. What about 5?
C.
C. C, senor. You're correct. What about 6?
A.
A. You're right. Guess you got an A for today. What about 7?
E.
You said E? Hopefully that's not your grade, but yep, you're right. And 8?
I.
Now you got the I. I would say you're right. You got a good eye with that one. And number 9.
D.
D. Done. We are done. No, we're not. We've got one little thing on us to do. On the next quiz coming up, look at this page right here. We got to know how to do this stuff. We got to know where functions increasing and decreasing and how to write the answers using intervals. These on your next quiz. I hope you know what you're doing. Remember, you read a graph from left to right. This has arrows on it. 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 These are all warm-ups. These are on your next quiz. You may be able to do them. Please note, what I tell kids to do is note, increasing is right here, from left to right. Left to right is increasing. See the yellow shaded region? Decreasing is where it goes down from left to right. See the pink region? So what I would tell kids to do is write INC, INC. And then over here is DEC. Can you tell me the interval where it's decreasing? You should all be able to do that in seconds.
Negative infinity 2.
You said negative infinity to what?
2.
If you do that, you're going to get
Infinity
spanked.
to 0.
There you go. Negative infinity to what? 0. Please note when you do this kind of stuff, you're using the what axis?
X.
So the person that said negative infinity to 2 is reading the y. That's why a lot of kids get this problem wrong. So be careful. Where else are you increasing? Can't hear?
To infinity.
2 to infinity. So there's that one. That's INC. Where's DEC? Where's it decreasing?
0 and 2.
0 to 2. And a problem that has continuous function like that, we use parentheses. Look at the next one. Try it yourself. That has a definite starting point and a definite stopping point. This is left to right again. I color these because most kids don't know how to read a graph, so I'm showing you where it is. Who's telling me where it's increasing? Can't hear you. This doesn't take all day.
1 and negative infinity, or 1 positive infinity.
1 to infinity. This time you'd use a bracket because it starts at 1 itself. That's a continuous function. It goes on forever. Where's it decreasing?
Negative infinity to negative 1 bracket.
Thank you, dear. That's correct. So make sure you can do that stuff. Look at the next one. They want the zeros. What do you do to find the zeros? Can't hear you. When it says find the zeros, what do?
Make f of x 0.
Thank you. You set it equal to 0. X cubed minus 4x squared minus 9x plus 36. Most kids get these wrong because they put 0 into the function and say the answer is 36. And I go, you're spanked again. That's the y-intercept. This is 4 terms, so you factor by what? Grouping. Please note the second term right here. There's a negative in front. That means you factor out a negative. That means that's x minus 4, and it equals 0. If you factor out x minus 4, you get x squared minus 9. That's x minus 4. X plus 3. X minus 3. What are the zeros?
4, negative 3, and 3.
Excellent. I'll put it this way. I'll put them in order. Negative 3, 3, and 4. Okay? Domain. Should take you a second to do that problem. Use interval notation. Answer. When we do domain, where do we look?
Denominator,
What can it be?
9.
Draw a number line if you don't know what you're doing. Here's 9. Open circle, because you can't use it. Can I use 10, 11, 12, 100, 1,000?
Yep.
Can I use 8, 0, negative 1,000? Can't hear you. Can I use 0?
Yes?
Yes.
It sure can. So it's all thing go that way. This is infinity. This is negative infinity. So it's negative infinity to what?
Positive infinity.
No.
Oh wait, 9.
9 union what?
9
9 to
to
positive infinity.
Please note, you have to know how to do this stuff. I highlight all the answers there. That's where increases, decreases, increases. You're using X intervals. Well, with the next one, they want to know is it odd, even, or neither. Well, you have to plug in.
negative x.
Negative x.
F of negative x equals, if I write x cubed minus 5, if I plug a negative into something cubed, it stays as negative. Look at the original function. This is how you do this stuff. Is it the same function as the yellow? What I did? Is that the same?
No.
Is it the opposite?
No.
So it's what?
Neither.
Do the next one. No, I plug in a negative. What happens? Look at the original function. What's the answer? Is that the same function?
No.
Is it the opposite of the function?
Yes.
It sure is. If you look at that negative, it says the opposite of that whole thing. So this is called a what function? Because it's opposite. Take a minute, do the last 4 yourself. Look here, there's A graph, B graph, C graph, D graph. There's the graphs. If you didn't see that again, it's A, B, C, D there. A graph, B graph, C graph, D graph. And you got 4 choices. You write A, B, C, D on the 4 choices. Takes seconds to do. What I tell kids to do is make sure they focus in on the scales. That looks like 0, 1, 2. That looks like 0, 1, 2, 3. That's by ones. So is B. But if you look at C, it says 2, 4. And then 2, 4 up, and then -2, -4, -6. And then it's going by 2s. The next one, D, goes by what? 4s, 8s, 12s. So you see that? You got to watch what you're doing. There's 2, 4, or 4, 8. Yeah, it would be the next one. Well, whatever. It's a little off, but whatever. So what graph is A? The parent function of x cubed. If you don't know what it's like, draw it. That's what I would do. It's a cubing function. This is the parent function. This is what it looks like. You look at A, what happened to it? It got reflected where?
Over the x.
The what axis? The y-axis. Right? And it got shifted up what?
1.
So what graph is that?
Oh, the last one.
So there's A. Done. What about the next one? This is the parent function. The vertex looks like it moved to what? 1, 1. Which one is that?
The second one?
The second one. It's B. Please note. The next one. The vertex reflected over the what? Y, and it got shifted what? That looks like -2, maybe -3, I don't know. -3, 1, -1, -3, -1, it looks like. Which graph is that?
The first one.
So you're going to call that C, I see. And the last one is what? The vertexes look like 10 what? 10, -4. That's what it looks like. And that would be what? D. There you go. Now, what do you get to do? Well, if you turn the page, there's a chapter review warm-up right here. This is what I want you to do in addition to the book work. So when you read your homework from the Chrome tab, this is what you're doing. You're doing this worksheet too. So this takes about a second to do, so I don't want to hear you cry. You better know how to read graphs. This is what we'll go over the next time you come in on Monday, and then we'll take the quiz. Any questions? Any questions?